Hi guys, all right. Good day and welcome back to Study Express Academy. So I know you guys have been awaiting the physics class, right? Yes. So it's starting right now. Yes, definitely it's going to start right now. So just I want you guys to send a message, and for before our teacher comes in and before he's already preparing, he's getting ready for the class. I want you guys to subscribe. Okay. So just click subscribe button on our YouTube channel. I want us to move this up, and like I said it earlier in the previous video about an hour ago, I said your like, your subscribe, your subscription to our channel is really going to boost us. It's going to make us know that there are students out there who are really they are gaining from what we're doing, and then it gives us this energy, it gives us this sense of responsibility that we're responsible for some students success out there, and then what we are doing can actually bring positive change. Okay, so that's why you guys should please support us by liking and subscribing to our YouTube channel. Okay, so don't forget that there's always a number across the screen. If you are joining, you just encounter this video, and then probably you want more information about our classes or how to join us, you can send the message to that video, or even you have any question whatsoever, that's our official phone number. I mean, you can message through WhatsApp. We're going to reply you in real time. Okay. So also, immediately this class is over and you're not in our WhatsApp group, make sure you request for the WhatsApp link from that number, and I'm going to send it to you so that you're going to get updates. Okay, you're going to be getting updates every weekly update, because we do have brainstorming sessions. Yes, we have brainstorming sessions where we open the group for students, to ask questions, probably challenging questions they encounter while studying, and also give answers. In fact, sometimes ask questions or ask explanation about some topics, and then where their fellow students answer the questions. In fact, if there is not any student that can actually answer the question, then the tutors are going to intervene by answering the questions. Okay, or in case a student propose a solution that is not right, and then the teachers can always come in, or tutor can always come in to know what to make corrections to that. So don't forget to subscribe. So you can just subscribe now, and if you are ready for the physics class, type I'm ready. I want to see you guys type I am ready. Okay, so do that now. If you can get up to 10 reactions, and then I'll tell you that your teacher is around and is going to come in immediately. So I want you guys to type I am ready. Okay, type I am ready. I am ready. Okay, I'm waiting for you guys. Yes, and don't forget to subscribe. Okay, subscribe, like. You can always share the link to your friends. Let them enjoy. Don't forget the topic for today is what is force concept. Yes, so our tutor is going to break it down for you, and is getting ready for the class sincerely. We want just to tell you guys to get ready. Hold your pen and paper. If you have a calculator with you, you might need it. Take it beside you. In fact, you can have textbooks with you. Maybe you just want to go through some things so you to understand it better, and then to follow up in real time. Take it. If you have past questions also, where you can see some things where you can work on immediately, or some questions you have whatsoever, you can always take them with you. Take your study materials with you, and then you're going to enjoy us in the next few minutes. We're going to start. Okay, thank you very much. And our tutor is here and is going to come in a few seconds right now. Thank you.
Okay. So sorry. So just that you can't hear what I'm saying properly. So let me increase my no my voice. So now let's take some objects so you understand exactly what I'm trying to say. So let's take we have if I have an object here now, this object is staying on the surface. So for the position of this object to change, definitely what it is going to cause the object to change its position. That is the action of what we have a force. Like I told you, very simple definition of a force. I told you what is force is. Force changes, the position of her mass. Hope that is clear. I told you so. If a force is unbalanced, definitely what's going to be the action of the force on the object? The object begins what to accelerate in a particular direction. Now, let's take a good example. Let me just give you this as okay. Now, I need to explain what a contact force is. A normal contact force, yeah, contact force are push or pull force. So what does that imply? A force that can change the position of an object by either pushing it or you pull it. So we call that what contact force. What the opposite of that is called what a distance force, also known as what feed force. So there are four common contact forces which you guys need to know. And what are those contact forces? I've told you, please don't forget. I said the contact push and what they are pull. Push or what I said pull. Now what are the contact forces? So this is the mass. So if I drag this object in this position, actually that's going to be direction of motion or acceleration of the body. The force in the air, so I can say, so if this body is pushed in this direction, meaning what I'm exerting the force here, or let me just use pull, so that's going to be clear. So if I pull this object in this direction, what's going to happen to it? So definitely its direction of acceleration would be towards the direction of the force. Of that is clear. Now, what is the other one which have on below here? That represents what the weight of the object. So the weight of an object is just the length of action of the gravity. So and your weight basically shows difference between what. So now mean the direction of weight always acts in what direction? Down. Now there is another force which you need to know. When a body is placed on the mat on a surface, when a body, I repeat, is placed on the surface, if the body is pulled or pushed on this surface, what are this surface does? It exerts vertical forces on it. I repeat, this surface itself also exerts vertical forces on it. And what do you call that? That is called a normal. We call it normal or reactional what force. So meaning, what does that basically imply? So the surface itself also reacts. Do you understand? If I try to pull this mass on it, just like if someone if someone try to push you, you try to react back. So the surface also reacts. Our reactional force is always perpendicular to the surface. So the reactional force always perpendicular to the surface. Don't forget that it's always perpendicular to the surface. Don't forget that it's always perpendicular to the surface. So let me use R for the reactional force. So if I don't use R, I can use N. Some textbooks use N. Do you understand? Small letter N, mind you. So that's it. And actually, when a body is pulled or pushed on a surface, something try to, oppose the motion of the object, which implies that if I try to stop pulling this object, it's going to stop by itself. And what causes the object to stop is known as what? The friction. So definitely what does friction mean? So friction opposes the motion of what of an object. So if I pull this object, which is the direction of the motion or acceleration of the object, so what is it going to oppose it? So my direction from the oppose, meaning it acts against. You understand? It has an opposite direction to the motion. So therefore my friction will always point. So my friction will always be towards this direction. So let me use F. So you can use small letter F to denote what you have your friction. So from here, so friction opposes what you have motion. And I've also like to explain that when the body is full of push on the surface, what's going to happen? The surface, what do you have an exact force in it? You understand? And what do you call this force exact by the surface on this mass is called what? Reactional or normal force. And in addition to this, your frictional force is always directly proportional to your reactional force. I repeat, your frictional force, which your head here, so it's only direct proportional to what? To our reactional force. So if I try to remove this, if I try to, which as the frictional force increases, what happens to your reactional force is also increases. And the question is why? Therefore, this is going to take me to two kind of friction you guys need to know, which are the static friction and the kinetic what? And the kinetic friction. So let me try to remove the proportionality sign. I'll be having what? So we have, so let me pull this for you like K. So what does K means? K means what? Kinetic, what they have a friction. What a kinetic friction, that is when the motion from the kinetic. So kinetic means what the body is in motion. So friction that tends to oppose the motion of an object while it is in motion is called what they have your kinetic friction. So now please, so let's remove this. So I'm gonna have, so we have a constant. So this constant is called your mole. You understand? So it's called, what do we already say? We call it what? So your mu. So what does this mu basically implies? So actually, this mu is a constant, and for every surface in which a body rests on, for every surface it has its own whatever, it has its own, its own mu. So we have for its ice, or for on the surface of a wood, or on the surface of a tiles, it always have its own what? It always have its own constant value, which is mu. So now please let me, so with our arrow. So yeah, we can. So what kind of constant is this? So you also denote is, the body is in motion like I told you, so we put what? K. So what does K means? Whatever, it shows whatever is in kinetic, meaning it's in motion. Hope that is clear. So what do you call this? So this call, this constant I told you, we call coefficient of friction. What is the place? Coefficient. If I have two x, so if I have two x, if I ask you what's coefficient of x, the answer is what do you have it? 2. And I told you that friction and what they have your normal reactional force, both of them are directly proportional to what? To one another. So as your frictional force increases, what happens to your reactional force also increases. So definitely the coefficient of friction is denoted as this, which I told you a constant. So what kind of coefficient of friction is this? So we'll call it what? Kinetic. This is called what coefficient what kinetic friction look like. That is when the body from a static, meaning when the body is at rest. At rest means when the body is not moving. So when the body is not moving, so we say the body is what is at rest. So the friction that keep for the friction that keep the body in that state, if I try to apply the force on it, definitely call what? Static friction. So how does that look like? So I'm going to show you a graph. I'm going to draw a graph for you so you understand what difference between kinetic and what the other static friction is. But mind you, okay, let me show you that. So that's going to be very clear for us. So if I have something like this, okay. So let's make it like this. Pardon, and we have it this way. Okay. Now I'll be using this graph basically to explain what I mean by that. So what's happening basically here? Before the body starts to move, before a body starts to move, meaning the body is at rest, definitely what it is going to be is acceleration for a body to start to move. Before a body starts to move, meaning when the body is what is at rest. So when the body is at rest, its acceleration is going to be equal to what? Is equal to zero. So for the acceleration of a body to equal to zero, so there are two conditions, mind you, not that. So when the body is at rest, or when the body is moving with a constant velocity. Constant velocity, mind you. So I repeat, for the acceleration of a body to be at for the acceleration of body to be equal to zero. So when it is at rest, or when this body is moving with what? A constant velocity. When a constant velocity, meaning the velocity does not change. So if that is the word constant, we say it's uniform, it does not change. So it means what the acceleration is equal to zero. And what does that imply? When I get to Newton, I would let you to know. So let me just add something up to this for you guys. Now, please, when this body is at rest, meaning it's not moving. So if I try to pull this, if I try to pull this mass, meaning I'm applying what we have a force on it. So if I'm applying a force on it, so what's gonna happen? If I'm applying a force on it, do not forget what opposes so what opposes my force? Mind you, what opposes my force is what? It's friction. So what opposes my force is friction. So if I'm applying the force, so as my force increases, what happens to the friction as well? The friction also increases. But what friction is this? The body is at rest, it's not moving at all. The body is at rest, it's not moving at all. So I'm going to call the body of it. So static friction. So for your static friction in this case, so what does that basically imply? So for the static friction, as the applied forces increases, the static friction also what we have increases. Mind you, so let me complete my diagram. So these are reactional force. So as the applied force increases, what happens to the static friction? So the static friction also increases. So that's the purpose of this graph. So this graph basically shows that as the applied force increases, what happens to my static friction? So the static friction also what increases until it reaches a certain point, meaning it has reaches what the maximum. So when it reaches maximum, what's gonna happen? Therefore, the body slide over the surface. So the body tries to slide over the surface. So what did I call that point? So that point whereby the body slide over the surface, we say what? That is called limiting friction. So here, so I would say what my static friction has become what maximum. So my static friction here. So my static friction here become what we have it? Become what maximum. Why? Because it is, the right actually it is maximum. That is the applied force has overcome what we have has overcome the friction of the surface. So what do I call this? So this is called our limiting friction. So what is the limiting friction? So the limiting friction is the maximum applied force reach for a body to begin to slide over the surface. So in that case, therefore, we can always say that. So therefore, we can always say that your static friction is equals to or less than. So now, what's proposed there? So your static friction, this means sign means what? It is equals to what we have our applied force. So when it is equal to applied force, meaning it increases with what with the applied force. I hope that is clear. So when it becomes what maximum, so when it becomes maximum, what happens to the body slide over what the surface. And what did I call that? I call it what? Limiting what? Friction. So the one limiting the friction, so it's the maximum force reached, do you understand, for a body begin to what? To slide over what? Over the surface. So yeah, so what can we call this region? So we can call this our region, we can call what? Static what we have a region. So when the body now begins to slide over the surface, just like you have explained earlier, so when the body begins to slide over the surface, moving with what we have moving to a constant what we have a velocity. So therefore we call that what? Kinetic region. So we call that what we have a kinetic region. So if you check the region for kinetic region, so let's see. Let's check the graph. So when the body begins to slide over the surface, so it's moving to a constant water, a constant force. So let's check the region. So can you see this arrow? So yes. So now let's check. So this basically shows that what we have for the kinetic friction when the body begins to move over the surface. You understand? After the static friction has been what has been overcome. So this let us to know that what our kind our kinetic friction is less than what we have our static friction. How did I get that? Please look here and look at this point. So which one is up? Which one is down? So this let us to know that the kinetic what we have a friction is down. Static friction is up. I've explained this. So this let us know that what we have your kinetic friction is less than what our static what friction. So from the graph. So therefore, that's how we can conclude that what the coefficient of kinetic friction is always less than the coefficient of what static. So static friction. I hope that is clear. So what's the purpose of the less than? So this less than force means if the applied force is weak, the body will turn to the what to the position which is dragged from. But if the applied force is strong, that is when we can have what our static friction will be equals to what we have at this. That is if the static friction is what we have at the applied force is very very strong. So the body is about to move or is at the verge of what? Of sliding. Or we say the body as the static friction has reached is what? Is limits. So and at that point we call what limiting what they have a friction. Do you understand? And at this point, when the body slide over the surface, therefore it begins to move with whatever with the constant whatever with the constant velocity or uniform velocity. Oh, that's clear. And that region is called what kinetic what region. Oh, that is clear. I've explained what is less than this. That is if your what if the applied force is weak. The equal to sign meaning if the applied force what is strong and therefore the body a point is going to be reached whereby the as the applied force increases, the start frictional force also what increases, and a point reach where it become what maximum, and I'll call what your limiting what friction. Now get how many forces acting on this, guys? So we have frictional force, we have directional force. I have what my pull force, I have this. So all these are refers to what a contact force. So actually your contact force. Actually, if contact force, those forces are what they are in contact on the object which they act on. So that's no what called contact forces. So what are the examples of contact force? Weight, friction, and what they have the applied force. Also have a reactional force. Guess what? If I don't pull this object and I try to, and let's say I try to drag this object with a rope. So if I try to drag this object with a rope, so what do you call that? That's called what attentional force. Attentional force, that is what the force in a rope or the force in a string. That's called a tensional force. And when you try to use a rope to pull an object, so we call out what repeat, we call it what tensional what force. It might be a rope, it might be a cord, it might be a string. So that will call it your tensional force. And that might be basically inclined at an angle. So theta. So from here, give me an example of a contact force, tensional force, reactional force, weight, and what frictional force. That's it. Now come here. So your Newton laws of motion, you need to understand this for you to be able to understand how to deal with what, how to deal with forces. Why did I just explain friction? It's going to help us a lot because I'm dealing with a body with friction, a body on a frictionless surface and what with friction. So it's very important because I need to teach you know how to solve what some creating of forces. So if we're talking about what needs to know of motion, so three things are very important, and that be explain how force behave. Number one point, that is if our net force is equal to zero. But first, I showed you what's our force itself. Friction let need to let us to know that for body in motion, our force is equal to what we have a ma. So that's our net force. So what do you call your net force? Your net force is what? The resultant force acting on the body. Can I move on, please? Not forget. I explained earlier force. While force acts on the body, or what you define as force earlier is defined as what change the position of mass. It changed the position of what? Of mass. It's defined as what change, the position of mass. So definitely, so we're going to the formula for force. So your formula for force would be F equals what they have a head A. So what does that tell us? Your mass is constant. Yeah. And for if your body, please, I use this arrow. What does the arrow shows? When this mass is set into what? Into acceleration, into motion, it will always be in the direction of the force. So it's always be in the direction of the force. So if I try to pull a mass towards me, definitely the mass, or the mass, or it will also as the mass itself, we accelerate, or the motion of the object will also be in the direction of what? Of the direction of the force. So that's the meaning of this arrow. So for every when force acts on the mass, its direction of acceleration is always that of what? Of the force. Now the first one about tension of motion, it let us know that number one, if the net force is equal to whatever is zero. So for the net force to be equal to zero, what's the condition? The condition is number one, if the what, if the acceleration. So for F to be equal to zero, it implies that it basically implies your A is equal to whatever, your A is equal to zero. So if your A is equal to zero, okay, let me make it like this. So it's gonna be easy. So if F is equal to zero, the mass of the body is always constant. So for our F to be equal to zero, that it basically implies that what? Your acceleration is equal to zero. So if your acceleration is equal to zero, so I'm gonna get. So that basically implies that mathematically I'll be having what you have our M. Actually, M is gonna be always constant. For every body, it always have is what? Its own mass. Times what you have times what? Times zero. So what do you think I'm gonna have? I'm gonna have what? Is zero. So what does that imply? So it showed my net force is equal to zero. And for this net force to be equal to zero, what is the condition? Acceleration is equal to zero. For your acceleration to be equal to zero, two conditions. Note. And what are those two conditions? Number one, if the body is at rest. Number two, if the body is moving with constant velocity. So if the body is moving with a constant velocity, so those are the two conditions for what we have for the acceleration of body to equal to zero. And what does that imply? So what's going to be equal to your force? So your force will be equal to what you have will equal to what is zero. And this basically explains what? This basically explains that what the body is at equilibrium. So that's it. So the body is whatever is in equilibrium. So that's very, 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 very basic. So if all the sum of forces acting on the body is equal to whatever is equal to zero, so what does that basically implies? So it implies that the body is what is in equilibrium. So what's going to be the vector form? The vector, if I say vector, it basically means that the forces acting horizontally and the forces acting what vertically. If a force is acting what vertically, vertical, you check your graph. Your vertical is your y, your horizontal is your x. So if I say vertical force, what did I mean by that? That is Fy. If I say horizontal force, what did I mean by that? That is what? Fx. So like, I mean, if I have your vertical, this, what in the call it? This one have y, right? So I also have what do you have x. So if a force is acting vertically, so I'm going to put what? We represent it as something like this. If a force is acting what do you have vertically, we put what? Fy. So very simple. Now, check. So yeah, I just want to explain that. I think this is clear. So what's going to be also the forces acting what we have vertically, That will also be equal to 0. So place. So what does this symbol mean? It means that sum of the vertical forces will be equal to 0. And so, sorry. So what's going to be this? What's going to be the horizontal forces too? Is going to be equal to 0. I beg, what condition is this? If the body is at equilibrium, and for the body to be at equilibrium, what's the main condition? This is the main condition. And what's the main condition? The main condition, the acceleration is equal to 0. And for an acceleration of body to be equal to 0 at rest, or the body is moving with a constant velocity. Do you understand? What mean of constant velocity? Very simple. The velocity of the object does not change. Or you say what? Uniform what they have a uniform velocity. Now that is also the first, this is called your Newton first law of motion. So actually your Newton first law of motion also explains the tendency for a body to be at rest. And that is called what? Your inertia. Your inertia is a tendency for a body to be what? To be at rest. Do you understand? Or the body to be moving with a constant velocity in a straight line. A good example, a car will no get brake. If the car does not get brake, do you understand? Or a car that has what? Brake failure. How will the car be moving? So it shows that the force acting on the car is what is going to be equal to 0. While the car is moving with a constant velocity. Do you understand? So that's a very good example. Or if I roll a disc, what force that is keeping the disc to be moving? I beg, no force is keeping it to move. Do you understand? So the force is equal to what? 0. The body is moving, yes, but with what velocity? The velocity is constant. The velocity is uniform. The velocity does not change. Hope that is clear. Now, what do you also call that kind of inertia? We call it what? Inertia of what? Motion. At rest. If body is not moving, inertia at rest. We also have what? Inertia what? Of motion. What is inertia? Inertia is the tendency for a body to be in this state or to be in what? To be in this state. Very simple, and that's it. Now, hope that is clear. So that's why we can also just say your Newton first law of motion. What does it say? I beg, I don't explain now. Is that what? It's basically explained for a body to be at rest. A body will be at rest, or a body will be moving with a constant velocity. Do you understand? If no force is acted upon it. So that's what we call your Newton first law of motion. That is the first law of motion. So the first law of motion said that a body will be at rest or moving with a constant velocity in a straight line. Those are the two conditions. But that's clear. Unless it is acted upon by what? By force. So what does that imply? Abeg, please. So the second one, abeg, the second basically shows the relationship between what? Between this second basically shows the relationship between the net force and what? An acceleration. That is all the forces acting on a body. All the forces acting on the body is equal to what? The net force. That is, if the body is set into motion, if a body is set into motion, meaning it is accelerating. It is accelerating. So what's going to be the net force? The net force acting on it will be equal to what you have, will be equal to what you have, ME. So your Newton's second law of motion basically show the relationship between the net force and what? And the acceleration. I hope that is clear. And I trade you place. If I have a ball and try to kick, if I kick this ball, what's going to happen? So this ball is going to accelerate in this direction. So what does that imply? So what law that explains this? So the law that shows the relationship between the force and what and the acceleration of body. So that is called what your Newton's second law of what? Of motion. So what does that imply? This acceleration of this ball, the ball will move fast or move slow depending on what? Depending on how effective the force acting on it. So what does that basically tell you? That tells you that what? Your force, the applied force, will be directly proportional to what? To the acceleration. At constant what? What is being constant here? So what is constant here for you will be, guess what? So what is constant here for you that does not change is the mass. The mass of the ball does not change because the mass is constant. It does not change. So the mass is constant. Hope that is clear. if I kick this ball, what's going to happen? The ball's going to accelerate. So the direction of acceleration is the direction of the what? It will always be the direction of the applied force. So how effective the force depends on how the body is going to what is going to accelerate, and your mass will always what constant. So that definitely mathematically, if you say what the force is directly proportional to what your acceleration. Now, guess what? Remove this, just like the way you do. So what now constant? Our constant here is what? And I have this. So what does that imply? All the net forces or the sum of forces acting the sum of forces acting on this object is equals to what we have here is equals to ma. So that's what we call your Newton's second law of motion. And the last one shows what? The Newton's third law of motion basically shows the interaction between two forces. The interaction of force. I repeat that. The interaction of force between two what? Between two bodies. Two bodies interacting, they are interacting together. And what are the two bodies? A good example, if I try to paddle a ship. Now, what are the two bodies? I have the ship moving on the water on the sea, and likewise, I use the paddle to set the boat on the sea into motion. And what are the two bodies? The two bodies there are what and what? The ship and the what? And the paddle as well. Now, guess what? So what are the two forces? So the two forces are your action your action and the reactional force. So this for every action, there's an equal but opposite what for every action. So this action sets the body in what? In motion. How the body reacts to the what to this action is the reaction of the object. So this set the body into motion. So if this set the body into motion, how the body itself reacts to it. So that's what our reactional force is. So definitely for every action, there's an equal but opposite reaction. There's an equal but opposite reaction of the body to it. So we put the minus there. So this minus means both of these two forces are what are equal, but they are always what they're opposite to each other. So if I want to move fast, so what makes your walking possible easy for you is Newton's third law of motion. If I'm running, I'm stepping on the floor. So what's gonna happen? That's my action. The more I move fast, the more my body moves fast, is the word reaction of the action. So they are equal but opposite. So this is called your Newton's third law of what? Of motion. Now, see something. So these are basically called concept of forces. And how do you see? I'm going to merge both of them together. That is friction. I don't care what friction is. And I've first explained the very brief concept on what force itself basically means and how to apply it. Don't forget, if the body is at equilibrium, I've explained it. If the body is not at equilibrium, that is what your Newton's second law of motion. If the body is at equilibrium, that is what first law. If the body is not at equilibrium, meaning if body is not at equilibrium, what does that imply? It implies that the mass is what? The mass is not the mass is moving. So the mass of the object, the mass is setting towards an acceleration. So that is your Newton's second law of what? Of motion. So let's see a question. If I ask you this question, okay. Let's see. Okay, let me say I have a 10, I have 5 kg mass, which is placed on this surface. So I have a 5 kg mass and it is placed on this surface. Mind you, please, must know the condition of the surface. If the surface is frictionless, meaning there's no what? There's no friction. There is no friction acting on it at all. So calculate the acceleration of this mass. So if I were to calculate, this frictionless means no friction. All that is clear. So, and let's see, I want to calculate the acceleration of this mass. So if I pull this object, will this object pull a spool bar force of, let's say, 10 Newton. So what's going to be the direction of acceleration? So the direction of acceleration, so the direction of the acceleration, because the direction of the acceleration, the direction of the acceleration of the objects. So the direction of the acceleration of the objects, A, do you understand, is also the direction of what? Of the force. Please, can you see? So that's what we call unity circle of motion. So this body is not at equilibrium. That is not at rest. Nor the body is what is moving with a constant what? Velocity. So what law I'm going to apply here? First law or second law? The answer is what we have there is what? Second law. So what's going to be the acceleration of this? Mind you, please know the nature of the surface. What did I call the surface? Frictionless, no friction. Aha. So can I move on, please? So what's going to be the acceleration? So I'll be using your Newton circle of motion, and now we call your F equals to what do you have there? NA. So what's going to be your acceleration? So your acceleration here we call what? The force over what? Over the mass. So what's the force? I have 10 Newton, and what's the mass of the object? That's 2. So what am I going to have? I have 2 meter per second square. So that's going to be the what? The acceleration of this mass on this what? On this frictionless what surface. What if I also have an inclined what? Inclined surface? So I have a mass of 10 kg is placed on this what? Is placed on this surface. Okay, let me say a frictionless surface. So on this frictionless surface, a mass of 10 kg is placed on this surface. So what is going to happen to it? Do you know what's happening here? Just let's say this is a ruler, and I try to place this marker on it. If I place this marker on it, what is going to happen? It's going to come down. So what did I call it? So this surface is frictionless. So it's going to come down. But at what angle, please? What's the angle of inclination? That is what 30 degrees. So in this case, the surface is frictionless. So if the surface is frictionless, so what's going to be the force that makes it what to come down? So is the body at equilibrium? This body will never be at equilibrium. So which one do you think I'm going to apply? So the question is, if would the bodies be at equilibrium? The answer is yes or no. The answer is what? No. Yes. So the answer is yes. So the body is at equilibrium. The question is, why is the body? How is the body at equilibrium? Oh, come here. Actually, for a body to be at equilibrium, there are 2 conditions. Either it's at rest or moving to a constant velocity. So if the body is on a frictionless surface, what is that? It's going to be sliding down or moving with what we have there with a constant velocity. It's going to be moving to a constant velocity. Since it's moving to a constant velocity, so it's at. So let's say. So I'm going to solve this. So it's very simple. Look at me and check how to solve this question. Yeah, I'm going to show you what called the free body diagram, and this free body diagram will really help you a lot. So if you see this question in your jam, just do the free body diagram. The free body diagram is very, very important. In physics, you must know your free body diagram. Are you good to go? Now let's see. So the free body diagram here, just pick the mass. The mass I have here and draw the what and sketch the free body diagram of this mass. And how to do that is very simple. So come here. So what's going to be the direction of the weight? Okay. The weight acts downward. Okay, let me bring it down. So I'm going to draw the free body diagram using the weight of the object. So using the weight of the object. So the weight, are you there? So come here. Just draw. this, and yes. So get so this direction is, so that's the weight of the object, which is, your W. How that is clear, because the weight of the object will be acting downward. So this direction shows what the weight of the object. So let me make it more longer. So that's just your free body diagram. So your free body diagram shows the forces acting on the body. So I have the weight acting on it. And don't forget, if a body is on a surface, I've explained that before. If a body is on a surface, if it is slide, if it is pull or push on a surface, the surface itself also reacts, and now called what your reactional forces. So your reactional forces is the force exerted on a body by surface, and that is always perpendicular. So let me use red marker for that. So these are your reactional forces. So that's the reactional forces. Your reactional force, so by the surface, and I told you the surface is frictionless. So let's continue. Now come here. So what are the force I have? I've explained this before. Look at this. This is horizontal. Before I showed you, this is horizontal. This is what? Vertical. This is horizontal, and this is what? Vertical. The vertical component of what? And the horizontal of what? The horizontal of this weight, and what? The vertical. This area shows the vertical of this weight. So this is the vertical of this weight, and what do you have here? The horizontal what of this weight. Now look at, if this is 30 degree, what did I have here? This is 90 degree, and the angle I have here, your angle is also what? Is also 90 degree. Your angle is also 90 degree. So if this is 30, what do you think is going to be the remaining angle here? The remaining angle here will be what? Will be 40. So if this is 40, this angle I'll be having here will what? Will be 30. Let me come again. I said that if this, I repeat. So if this is 30, this is your 90 degree. So this is your 90 degree, your sum of angle in a triangle. So what's your sum of angle in a triangle? Your sum of angle in a triangle, so this is 30. So this is 90. This is going to be what? 40. So if this is 40, what is going to be the angle that is going to be here? Everyone, so the angle that's going to be here will be equals to what? Will also be equals to what? 30. Why? This place here, this is your 90 degree. This is your 90 degrees. This is 90. So if this is 90, so if this is 40, the may not become 30. So that's how I get what your 30 here. I hope that is clear. So very basic. So that's we call what we have here. That's what I just draw here for you. It's called what we have here. It's called the free body what? The free body diagram of this body. So how do we now solve? Very simple. Hope that is clear. Uh, Now, get what? Just make your right angle triangle, and that will call triangle of what? Of vector. So your triangle of vector, what does that imply? So if I can see two forces acting on a body, so their magnitude and direction can be represented by what? By the side of what? By two sides of a triangle, and their resultant, which act in opposite direction, serve to be the hypotenuse of the triangle. So that's your triangle of what? Triangle of vector. So how can I represent this? Well, in triangular form, just draw a rectangle. If you draw a rectangle, bring out what? The triangle. Draw a rectangle, bring out the triangle that is inside. So if I bring out the triangle, how the triangle look like? So let's just draw a triangle, a rectangle here. So just draw a parallel line, your parallel line. So the way you always do, your parallel line, bring another parallel line towards this. Let me use a red marker so that you can see that. So if you check, so this is your rectangle. So this is your rectangle. So let's just bring the triangle. So with this triangle here, it's parallel. This is your horizontal. So this is your what you have your hypotenuse. This is your hypotenuse. How did I know it's the hypotenuse? Any side that is facing the right angle triangle, this that is facing the right angle is called the hypotenuse. So our hypotenuse is our weight. Can you see? So now that's called what triangular vector. So triangular vectors, especially you need triangular vector a lot when you're solving what? When you're solving forces. You need triangular vector a lot. Oh yeah, I beg, bring this triangle out. So what's the triangle, everybody? So the triangle, I think you can see the triangle. I beg, bring it out. So what did I have? So let me just bring it out for some people that cannot see. So this is the triangle here. So we have this one. We also have this. So that's the triangle. So your 30-degree, this is it. Here, this is your weight. Now, what is this horizontal? This horizontal. So this is horizontal. I tell you, horizontal force. We represent that with what? With Wx. That is Wx, that is horizontal of the weight. The vertical of the weight will be represented with what? The vertical of the weight, of this weight that we have here, will be represented with something like this. So if I also have force here, if I have F, so the vertical of F will be Fy. The horizontal of F will be Fx. So that's how to, to do components of a vector in physics. So let me just complete this. Why did I have to come back? I just want to show you something. So what did I call this? This will call your triangular of what? Your triangular vector. Your triangular vector, I showed it before. If two forces, let's say this and what this, are acting on a body, they're acting on the body, their magnitude and direction can be represented by what? By two sides of what? Of a triangle. By two sides of a triangle, while their resultant act in opposite what? Direction. So this one, is up, is facing up. Abi, this one here is facing this direction. So this one is parallel to this. So this is parallel to this. So both of them are parallel. Let me help you to show you. So they are parallel. So I represent this one with what? WI. So both of them are parallel. So this is called your triangle of what vector. I think you've learned a lot today. So what's going to my WY? What's going to my what? WX? You know your SOHCAHTOA. Your SOHCAHTOA, your SO. What do you have here? Ka. And what do you have? Toa. So what's your SOHCAHTOA? Your SOHCAHTOA. Your O here is opposite. If I want to get opposite, how did I get opposite? Opposite is equal to hypotenuse sine theta. Adjacent is equal to what? Hypotenuse what? Cos theta. So from here, what is opposite of the 30? The opposite of 30 is WY. What is the adjacent? The adjacent is what you have here. Your W what? Your WX. This is the opposite. Opposite means where it is facing, where this angle is facing. Why the adjacent is called what? Your WX. So how did I get to my opposite? From here, just cross multiply. Opposite, cross multiply, hypotenuse sine theta. Adjacent, cross multiply, hypotenuse cos theta. I'm teaching you how to do vector. Now, if you now come here, if that is very, very clear, now come here, I beg. What is the opposite of 30? WY. So I write what? WY, that is the opposite. And I told you what's opposite. Just cross multiply. That become what? Hypotenuse sine theta. Just cross multiply this to this. So what's the hypotenuse of the triangle? Is W. So what do you have here? Sine. So what do you have here? The theta. And what's your theta? Is 30 degrees. All that is clear. And what's your WX? Your WX is the what? Is the adjacent. Just cross multiply. So if you multiply, what do you have here? The hypotenuse. What's the hypotenuse? So the hypotenuse is W. Cos. Your C stands for cos. Cos what? Cos theta. Your theta is the angle. That's how to solve what your normal vector. I beg. Let's just solve this one. You see, this is how to resolve what vector. We're dealing with what? We're dealing with physics. You need to know how to solve physics. It's very simple. It's not hard. Just know your sense of geometry, your trigonometry, and some basic little of mathematics. You understand how to solve what physics. So from here, so what's your? We've already know. We've already know what. We've already know what our weight is. So what is our weight, everyone? Mg. So what do you have? Sine theta. So what do you have? Our weight is mg, and that become what? Cos theta. So these are just what to resolve forces. Now, what is our final answer? I beg. So to solve this question, actually, if this mass is placed on a frictionless surface, what do you think is going to happen? It's going to move down by itself. With what? With a constant what? Constant velocity. So if you slide it down, guess what? What is bringing this body down is going to be what direction? I showed you before. The direction of a the direction of acceleration of a mass is the direction of what? Of the force. Do you understand? They're always in direction. That's why I put this arrow here. So in what direction is this body sliding down? It's sliding down in this direction. And which is direction of what we have here? Your WX. You see? It's sliding down in this direction of what? Your WX. So which is that what is bringing this body sliding down is what we have here is our WX. And that's our answer. Very simple. This is the direction of the acceleration, the body is sliding down here. So it's sliding down. So it's sliding down towards this direction. And so what's the direction of the force? So the direction of the force is also what? Your WX. That is clear. So in this, so here, so what am I going to be having? I'll be having what? Our WX. I already told you what's the WX is equal to what you have the mj what? Sine theta. That is clear. So that's equal to your WX. So that equal to md what we have the mj cos theta. So are you able to get what your answer? You know what your theta is? Your theta is 30 degrees. You can be asked, let's calculate the acceleration of this body. So our weight is our gravity. So do you understand? So your weight is gravity. Your g rather is gravity. So what's going to be the direction of acceleration of this body? If it's sliding down on a frictionless what? On a frictionless surface. What's the force acting on it? Is what they have what? RWX. So I hope that is clear. So in that case, so I'll be having which law of motion am I going to use? I'll be using what? Your second law of motion. And that becomes what you have your mg cos theta. That is, what's our mass? Our mass is 10. Okay, let me write it for you. That becomes your wx. It's sliding on this surface equals to what you have ma. So, and what's our wx? That is mg cos what do you have? So the cos of the angle equals to what do you have? Equals to ma. So mass we cancel what do you have? Mass, and we'll be having a to the equals. What's our gravity? Our gravity is 10 cos what? Cos 30. Do you understand? Cos 30. And what's your cos 30? Your cos 30 is equals, press this inside the calculator, times what do you have? Times 10, which is your gravity. Do you understand? So your gravity, please. Your gravity is 10. Your gravity is constant 9.78. So your 9.78. So I just 10 approximately. So so your cos 30 is 0.8. So multiply by 10. So what's gonna be your answer? So that's gonna give you what we call what you have. So 0.8 is your cos 30 times this. That give what? 8 point what? 8.6. If I approximate. So 8.6 meter what per second square. That is for a frictionless surface. It's just sliding down. This is acceleration, like it's sliding down, it's accelerating downward. Do you understand? In this direction of what? Of this force. So that's going to be what you have. You're getting second law of what? Of motion. So thank you. Don't forget, physics is simple. And how to solve physics is very important. What are the key? Your CAP. What CAP? Cap. What mean of CAP? This is the method of how to solve physics. What does it stand for? Watch out, subscribe. See you in our next section. Kí ni C? Calculation. A. Application. P.